Okay, so now we can look at the acid-base properties of salt solutions. So the idea here is you're going to take a salt, so something like sodium chloride, and we want to be able to predict that when I take sodium chloride and dissolve it in water, what kind of solution am I going to have? Am I going to have an acidic solution, a basic solution, a neutral solution? And just by looking at that salt, trying to figure out what is it going to make, what kind of solution. And so what you're going to do is you're going to take the sodium chloride. You're going to try to figure out how can I make sodium chloride? From what acid and base can I make sodium chloride? It's always going to be an acid-base reaction. So if I took like sodium hydroxide and I reacted it with hydrochloric acid, I can make sodium chloride. I can just do a regular double replacement reaction. Remember, this is a strong base and this is a strong acid, and I can put my my cations down here. I have sodium plus and H plus, and then they switch places. I have chloride minus, OH minus, right? And then they crisscross my um, I have 1 and 1. Okay, so that's sodium chloride, and then this is 1 and 1, so that's a liquid water. So how can I make sodium chloride? It can come from sodium hydroxide and hydrochloric acid. And because this is a strong base and this is a strong acid, two strong things are going to completely neutralize each other. And so if I add a strong acid plus a strong base, the resulting solution will be neutral. The salt solution will be neutral. If I had a strong acid and a weak base, it looks like an acid. It always looks like the stronger thing. Think of these are like the parents, and this one has stronger genes here. The stronger acid plus the weaker base is going to look like the acidic. If I added a weak acid and a strong base, it looks basic. Now, this is the tricky one. If I had two weak things, I have to figure out which one's stronger. Since they're both weak, a weak acid and a weak base, I have to compare their Ka and their Kb. So if the Ka was stronger, it was bigger, it was greater, it's greater than the Kb of whatever. They're not conjugate acid-base pairs. These are not conjugate acid-base pairs. So these aren't really, Ka and Kb are not really related. So the Ka, if the Ka is bigger than the Kb, then it's going to be acidic. That's like if the weak acid is stronger than the weak base, it'll be acidic. If it's the other way around, if the Ka is less than the Kb, then it would be basic. So that's a tricky one. You can't do that one just by looking at it. You have to compare the Ks and the Kb. So we're going to focus mostly on these three groups. Those are the ones I usually test you on. So you have to know your strong acids. You have to know your strong bases. This is pretty much impossible to do unless you have those already memorized. So make sure you go back and look at those in the beginning of the chapter, your strong acids and your strong bases. All right, so let's do a few examples here. Now, this is the way the book kind of explains it. An anion, that is the conjugate base of a strong acid, will not affect the pH. That's just really saying that that's going to make it neutral, and cations of strong bases won't affect the pH. That's why they're neutral. If you just take the acid, if you just take the salt and split it up into its parent acid and base, work every single time. So what I like to do is I just take, like we did with sodium chloride. We said sodium chloride, split that up into Na plus and Cl minus, and the cation and the anion part. Now to the cation, add OH. So I'm going to add OH to this guy, and to this one, I'm going to add H plus. So basically just splitting up water. So here I end up with NaOH and HCl, and I say that this is a strong base, this is a strong acid, so I know it has to be neutral. Let's try another one. What if we did like barium nitrate? So we have barium. I'm going to split that up into barium, 2 plus, and I have 2 nitrates. I don't really care how many I have. I'm just looking at the ions. What ions are making this up? To the positive thing, I'm going to add OH. So I'll crisscross that, and that becomes BaOH2. And to the nitrate, I'm going to add H plus. So I have H plus and H plus and NaO3, so my charges cancel. This is a strong acid. This is a strong base, so that's going to be neutral as well. So remember all your strong acids and strong bases. Strong acids are HCl, HBr, HI, HClO3, HClO4, HNO3, and H2SO4. Those are your strong acids. Strong bases are the group 1 metal hydroxides and the heavier group 2, so calcium, strontium, and barium hydroxide. So this is another one where that happens. One more. What's one more? Let's take rubidium perchlorate. So Rb and ClO4. So I'm going to split those up. Rb becomes Rb plus. I'm going to add the OH to that guy. So that's a strong base because that's a group 1. And then over here I'm just going to add an H plus. So I have HClO4. That's a strong acid. So those are all going to be neutral. So I'm going to give you the salt. I want you to take it and split it up, and then you have to figure out, okay, did it come from a strong acid and strong base? Did it come from a strong acid and a weak base? Well, it's always going to look like the strong things. If you have two strong things, they're going to completely neutralize each other, and then you're good to go. So here we have something. Let's try this one. Try RBF. I'm going to split this into RBOH and HF. Alright, plus HF. HF is a weak acid, and RBOH is a strong base, so that's going to make this guy basic. We'll do some more. Here we have BaSO3. So I'm going to split that up into BaOH2 and H2SO3. This is a weak acid. This is a strong base, so this is also going to be basic. Turns out everything that I write in this row here is going to be basic. And then another example, we had NaClO. I'm going to split that up into the first part, like the metal, I'm adding the OH, so NaOH, and then the other part is HClO. This is a weak acid. How do you know that's a weak acid? Because it's not strong. It's not on that list. NaOH is a strong base because it's a group 1 metal hydroxide, so that's also going to be basic. Let's look at this row down here. Let's try this guy. NH4NO3. NH4. Okay, so NH4, I'm going to add an OH to that. NH4OH. That's a weak base. That's actually NH3 plus water. That's okay because it's a weak base. You know it's a weak base because it's not a strong base. And this is HNO3. This is a strong acid. This is a weak base. So this is going to be acidic. Let's try another one. What if we had aluminum chloride here. So this becomes aluminum hydroxide and HCl. So you may be looking at that 3 and say, why do we drop that 3 there? Because this is an ionic compound. When I put this in water, it dissociates into aluminum 3 plus and 3 chloride ions. And I'm just looking at the chloride ion, so I don't really care that there's 3 there and there's not 3 here. It just means I have 3 of those if I want to put that in front. This is a strong acid, this is a weak base, so this is all going to be acidic. Alright, now the tricky ones, What if you had NH4ClO? Let's split that up into NH4OH and HClO. This is a weak acid, this is a weak base, so I don't know. I'd have to look at the Ka and the Kb, so I can't tell with just the information I'm giving here. I'd have to look up and compare the Ka versus the Kb. Same thing happens over here. I have CrOH3 and HF. This is a weak acid. This is a weak base. I don't know. I'm not going to give you those unless I give you the table of Ka and Kb values, and then you can compare. If the Ka is bigger, then it's acidic. If the Kb is bigger, then it's basic. So you can try a few more of these if you want to.